it was in one.
Yeah.
Now I changed it. Better. For the exercise one, we introduce the exercise.
I just give you this exercise.
No, no, the exercise.
Which one? Which one?
2.2.
2.2. I think two programs. Yeah.
Well, I was able to ask you that. For the first, I just read it by my other friends. And for the second, I just found something better. Hopefully that's right.
You what for the second? You can bring anything? The first version or the second version? What the first? Yeah, just need to just print it for the first question. For the second,
Okay, so let's get started. One thing you notice is that I changed the due date of the homework by a few days. It's because we are late in the progress of the lecture. So today we will talk. Hopefully today we will hit this checksum, so you can work on the checksum problem. But it may not be until Wednesday until we will talk about the sequence. So you have a few more days to finish your homework. So last time we stopped here. So we are working on the in-class exercises. So hopefully you all had some time to work on these problems on your own. So today we'll just talk about that, the solution together. So let's first review. The first problem is to write a simple server program that uses TCP. The function should be very simple. It accepts a message from a client, then print out the lines to a server standard output. Then the interesting part is you can use your browser as the client. So instead of writing a toy client program, you can just use a real-world browser. And you can direct your browser to the host that's running this server. then you can think about what's the IP address and the port number that you should use. Then you can see how does your browser talk to your server. And this is actually a very simple server program. This is basically to refresh your memory about what's the standard simple TCP server program. So first we specify the port number. Then we create a socket. So this tells you the operating system, this is a internet protocol. Then this string, socket string stands for TCP, it's a string protocol. Then we assign this port number to this socket, which is 12,000. Then this socket will start to listen to connection request. Here we'll enter into an infinity loop. Then you're just gonna wait for the client to contact it. Once it receives the request, it will accept that request, then create a new connection socket. So here are a few things you should remember. One is this accept is a blocking statement. That means when you execute this program, your program will just stop here. It will just wait until a client requests this connection. Once some client requests it, then you're going to generate a new connection socket. So the second thing to remember is this server socket actually is different from this connection socket. This server socket is a welcoming socket, but this connection socket is actually the actual socket that we will use to exchange data with your client program. Then here, the next sentence is we'll receive 1024 bytes through this connection socket. So one thing also you need to remember is this receive statement is also a blocking. That means it's gonna pause here until you receive some data from the client. Then after you receive these bytes, they need to decode to character. So remember the message that you receive is just bits or bytes. Somehow you need to convert that to characters. It can use Unicode 8-bit or 32-bit, but the default is Unicode 8-bit. So once you decode those bytes, you got a sequence of characters, then you can print it out. So after that, you can just close this connection. Of course, this is also an infinity loop. You can loop back here. Then it's going to wait for the next client to connect to contact this server. So this is our client. So in my computer, I just used Chrome to test it. All I need to do is just give it its IP address. So remember, this is a special IP address. This is the IP address of your own computer. Let's say if you're running a server, you give it this IP address. It will just contact whatever program that's running on your own computer. So now you use a comma here to specify the port number. So it's 12,000. That's the port number this server program is listening to. And this is the output that I had on my own computer. So you may get something different. So first we print out this message received from the client. That's the message we print out here. So this is actually the message we got from a browser. So the first line is saying that you need to get something that's specified in HTTP protocol. The version number is 1.1. And this is the IP address of the host. So it's extracting the data from. And then it wants to keep the connection alive. That means it's requesting a persistent TCP connection. You can also read the rest. For example, some of this is pretty obvious. Basically, it tells the server what kind of browsers this kind of using. It's a Mozilla 5.0. And of course, it also says what kind of language is specified in this protocol. So this is the first message. And you can see that actually my browser attempted another time. So this is the second time it tries to connect with the server. So the reason it attempts 3 times is the server connects the browser connects to this server, but this is what it sees. So basically it doesn't send any data. It's because our server is basically a toy example. It's not trying to send any data back to the browser. So here is an example that you see that how the client can send a legitimate request to the server, but the server doesn't understand how to parse this message. Right? But we can work the other way around too. So this is we can see the real get a request from the browser. But now can we write a toy browser use to send a request to a real server. So you can just use this get request. It's very similar to the get request we got from the Chrome. So get HTTP 1.0. So this is a /r means it's a return character, and a /n means it's a new line. And also we give it an IP address. So now you are asked to write a client program that sends this message to a web server at port 80 and print out the received message. So as an example, let's try our OU homepage. So first thing you can do is you need to get the IP address of a website, right? You can use the pin. So just type pin ou.edu. Then this program will get an IP address of the program and then try to calculate how much time it takes to receive the response back. So this is the timing here. So now this is the client program. This is a server IP address that comes from here. And since we are trying to do a HTTP connection, so the port number that the OU server is listening to is port 80. Then again, we are trying to create a internet socket with TCP. Then we try to connect that our client socket with the server socket at this IP address and at this port number. And this is our request. We just put it into a string. Then we just print out this request again. So you can check. Then we encode that request, this string of character into bytes. We send it through this socket. So again, remember, so this connect is also a blocking statement. That means you will wait until the connect is accomplished until you move forward. So this send is also a blocking. So basically, you will send it and then wait it to complete. Then you'll move to the next step. So now after it sends this request, then it's ways to receive a message from the server. The receive is also blocking. Basically, we'll just stop here until the server responds. So let's we only expect 24 characters back from the server. Then this is the response. Then we can decode that to a string. Then we print out. Then we close the socket. And this is actually a response I got from ou.edu. So this is the request that's sent out. So the first line you can see that it's responded to HTTP 1.1, so version number, 200 OK. That means it received a legitimate request. It also responded with a valid response. And this is the date that it sent this message back. This is a server program that's running this server. OU server is a Apache running on Red Hat. And this is actually modified 5 years ago. And this is somehow they moved this server. So it says this is a legacy web services. So that's it. So of course, in this case, our client program just print out whatever message you received in this text format. If this is a real browser, it should be able to parse all these HTTP tags and display it in a more user-friendly format. So by doing this exercise, you will get a good sense about this is a protocol between HTTP is a protocol that we use between a client, which is a web browser, and a server, that's a web server. So in this case, we used a toy example to interact with a real-world example. Because our toy example cannot understand the response, the messages, thus therefore it's not giving you any legitimate response. In order to actually develop a useful client and server, we need to understand the protocol. So that's what we're going to do in this lecture. Okay, so today we're going to continue this section, web and HTTP. So here is a protocol that's, remember, at the application layer. That means you receive a message from a server. And this is basically a protocol that specifies how the message should be interpreted. When you're trying to use HTTP, you are getting a web page back. When you have a web page, it basically contains these are objects. You can think of objects as files, but these files can be represent many different things. For example, it can be a JPEG image, a application, JavaScript, audio files. So this all are considered objects. Then the web page considers the base HTML file with many reference objects. For example, if you have a web page that contains a picture, somewhere you should have a tag to tell you where you should get this picture. And that location is specified by URL. It stands for Universal Resource Location. You can think of this as a directory. For example, this is the host name, and this is the path name, and this is the object. So typically, the real reference to actually a file on a directory in the host system. When you're trying to use a HTTP, you kind of send a request to the server, and the server responds to HTTP with a HTTP file. And you have seen some example like that. So for the request can be just a get message. The response is just a HTTP file. The server can communicate with multiple clients. The HTTP uses a TCP connection so it can get a reliable data transfer. That's the primary reason. And it uses a well-known port 80 as a communication package. So this is a communication between browser and a web server. So we also cover that in the exercise. So one thing you probably noticed when you try to use HTTP is in the protocol itself, it's stateless. That means if you're connected to the server, it doesn't remember what did you ask before. Of course, we all know that when you go to Google or Amazon, it remembers your browsing history. So that's accomplished by using a cookie. Or the browser can allow a server to put a small file, text file, that stores the previous information. By using cookie, the saved information is saved in the client side. So the server side doesn't need to maintain that information. So it's much easier to implement. There are two types of HTTP connection. One is called a persistent. That means you open a HTTP connection and you request one file. And after that file is transmitted, then you can close that connection. Then alternatively, you can create a persistent HTTP connection. That means you can use the same TCP connection and you receive many files that's referenced in a HTTP file. So the advantage of non-persistent HTTP is you can open multiple parallel connections. So if you download 10 objects, then all those objects can be downloaded through 10 different types simultaneously. But the disadvantage is this involves a lot of overhead. So this is an example. You enter a URL into your browser. Then this kind of need to initiate a TCP connection with the server. The server responds to the connection. Then request a file. Then the server receives the request. Then form the response message. It may have many objects. Sorry. And after you receive this message, the server just closes the connection, and then it displays. It parses this HTML file, and finally you have the 10 referenced JPEG objects. So now you have to repeat this 1 to 5 steps to do that for all these 10 JPEG files. Of course, you can do this in parallel. You just create 10 parallel HTTP connections. So you can look at it as an overhead. So first, it takes time to establish a TCP connection. It needs actually one round trip time. So this RTT means round trip time. Actually, you are also asked to do this in your homework. You are asked to calculate this. Then basically start a timer here. Then you stop your timer when you receive the response back. Then you can calculate how much time it takes for round trip communication. So in a non-persistent HTTP connection, you have to wait for this one round-trip connection to get the requested connection established. Then it needs to wait another HTTP round-trip to receive the files back. Then this is actually the time it used to transmit the files. So in total, to receive a request to a non-persistent HTTP connection is 2 round-trip time plus the file transmission time. On the other hand, if you use the persistent HTTP, you can remove these two overhead. So basically, you can start to request many files from this on. So this is, if you have 10 files, all those 10 files will be sent in here, one after another. But this is a sequential process. We can look at a few examples of the request messages. In the exercise, you have seen one. Here's another example. This first, we can start with a request line. It may be one of these few commands, get, post, head. So this is a get command. Then this is actually the object is requesting. Remember, if you remember in the ORX side, we actually didn't specify this request. So it's actually default to index.html. Then this is the protocol is actually sending this request. And this is a character return and then new line. After that, you have a few headlines. We looked at some examples. After that, then you should have an empty line here. Then following should be followed by actually the HTML file. So it specifies all the header and the body. This is a general format. You have a method, then space, then URL, then the version number of the HTML. Then some header fields, the new line, this is the body of the message. There are a few commonly used methods. So one is, we have seen the get files, get command. Then the post will actually allows you to submit a file as you fill up a form in a browser. Then somehow you have to give this information back to the browser, right? You can use this post method. It typically uses to post very small strings. Alternatively, you can also return information in a URL. So this is an example. Let's say you do a search on Amazon. You can see the URL specified in this way. So you use the question mark. Then this string here is your search term. So instead of using a post format, you can just use a get method. Then you just specify the message, the content in the URL. In the HTTP 1.0, there's also a header command, a header method that just asks the server to respond with the header and leave out the body of the message, the HTML file. And in the HTTP 1.1, you also have a new method called a put. Basically, it uploads a file in the entity body. So let's say if you are asked to upload a Word file, it can be encoded and uploaded to a server using this put method. There's also a delete method that allows you to delete the file specified in the URL. So after we send this request, then we can receive a response message from the server. And this is a typical response message you're going to get back. So the first line is a status line. And we have seen this example, 200 OK means this transaction is successful. Then this is also some header information we look at in our exercise. So it's, for example, it tells you what's the server OS, the time of the response. And again, we have an empty line here that separates the front header from the body. And this is actually the body of the HTML file. There are a few standard code for the status. So 200 OK, that means this is a successful request. Then this is a few others. You guys are all probably familiar with this 401. I mean, it's not fun. So if you go to if you type your web address wrong, so you typically will get this response back. There are a few other error code, so the client should be able to interpret this response and then behave correctly. Okay, so very quick, let's do an exercise on this application layer. You can go to the canvas and open this exercise. So this going to be pretty straightforward. I'll just give everyone about 5 minutes to work on this. You are given a example HTTP web page, and you ask to find the information. A lot of this information is very self-explanatory, so you can just look at the message.
Yeah, how do you even know if it's persistent or not persistent?
This one.
Can I check if that's persistent? Yeah. The version is version 1, right?
Yes, 1.1.
Open one there. And this is the micro.
I just put everything inside.
Where did you find that? Where did you find the URL?
Just combine this thing
What's that?
and then this thing.
Oh, so you run the host and add this
Yes.
okay to the end.
That's my understanding. I don't know if it's correct or not.
Okay, so
There are two types of questions. But how do you know in the message which one?
This is the request. This is the request message.
yeah.
Is it both of them or just
coming
the
from the
file
server.
path? Because that's what I couldn't understand.
I actually tried using the file tab. I think it's actually both of them.
Both of them?
Yes, no, please, and then you get
That
what
was
you
my initial reaction.
does the browser? What is the IP address of the browser?
I think it's just hosting. I think it's just hosting. I did a ping, but it won't do the same thing.
Are you paying it?
I'm not positive though.
Ping. Did you get 128.199?
Yeah.
Did you ping to get the IP address?
Yes.
Type of browser information. This message. It's the browser targeting this HTML. Did you get, how do you understand this? Is it in Mozilla?
Yes.
Why is the browser targeting this?
My understanding is because Zephyr might have several different versions of the HTML, and they will send them based on the type of the browser, requesting browser.
Because they need a different requesting process?
Yes.
All right, so let's
That's my understanding.
work on these questions together. So what is the URL of the document? It's right here. So the versions of HTTP, it's 1.1. The browser requesting a non-persistent or persistent connection. It's here, connection keep live, that means it's persistent connection. What's the IP address of the host on which the browser is running? IP address, the host. So actually here we didn't have a host IP address, we just have the host web address. So actually this is in the underlying the IP layer, we will get the IP address. But in this HTTP, we just have the host name. What type of browser initiates the message? That's a Mozilla.
On the IP address, if we ping the host name, would that be it?
Yes, you can get it that way. But one thing to know is that this message is encapsulated in the IP datagram. So another way, just look at the IP datagram. Why do we need the browser type? So this is because the server can actually send you different files based on your browser. For example, if you have Internet Explorer, it will send you one file. I mean, HTTP is supposed to be an international standard, so if everyone is standard compliant, they should have the same behavior. But in reality, Microsoft and Google, they all have their own particular way of interpreting HTTP. So that's why the browser sometimes maintain different version of the HTTP file. Okay, so this is the first question. So now this is a response. Was the server able to successfully find the document or not? So this is the first line. It says 200 OK. That means this is a successful operation. What time is this reply provided? So that's the state here. Then when is the document last modified? That's this line here. How many bytes are there in the document? Okay. Somewhere is yeah, this here, connection at length. What are the 5 bytes of the document being returned? So remember, we always had this empty line here. So after this empty line, this is the first 5 characters. Did the server agree to a persistent connection? Somewhere you should say, the keep alive, that means a persistent connection. So this is the exercise. So as you can see that if you want to write your browser, you just need to read the standard and then parse out all this information. So you should be able to write a very basic browser. Okay, so I think this is concludes our chapter 2. So you can see that we basically spend more time in the software programming. I feel